So here's that rule that I just stated. If your events are independent, we know, right, the probability of pizza given male is just equal to the probability of pizza. Knowing the person was a male changed nothing. So if we were going to use the formula up above, this could just get shortened to probability of M by itself, because knowing the dog was adopted didn't give us any new information. That wasn't true in this case, but that is exactly what happened in this formula. So this is something to only use if you see the word independent. There are times, yes, that you could decide things were independent, but for the most part, in those situations, you probably won't even be doing this. Just keep in mind, if you haven't seen the word independent, you probably aren't going to be using this rule. So let's see how this will play out on a potential test question. So our question here, again, read through it and then go do your underlining. 20% of SDSU students take Stat 119. 40% graduate in 4 years. This seems really terrible, but a lot of students just take longer than 4 years because classes are super impacted. So just like it takes students a lot longer than 2 years to get out of the 2-year colleges, it takes longer than 4 years to get out of a 4-year college. If these events are independent, what is the probability that a randomly selected SDSU student has taken Stat 119 or will graduate in 4 years? So it's clear that we have Stat 119 listed a bunch. We also have graduating in 4 years. And I have some keywords that are super important to me. I've got this keyword of or between my two events. And I have this keyword of independent. As soon as I see independent, I think, okay, sweet. That means I can write down that independent rule. Stat and graduate is equal to stat times graduate. I'm just basically, as soon as I see independent, I write down that rule from above. And now I'm going to translate all the stuff we were given. So we have 20% takes Stat 119 and graduates. So probability, that's another percentage. So that actually just split up my sentence. Don't get too excited by just circling ands, as you can see. So taking Stat 119, well, that is just 20%. Graduating within 4 years is 40%. And if they're independent, we are looking for the probability of Stat 119 or graduate. Now, one thing that students will get sort of excited about and just move forward with is they'll just use this and probability and think they're done. But we're not asking for and, we're asking for or. So we have to remember that the or formula is the probability of S plus the probability of G minus the probability of S and G, right? I wanted to use my cute colors, but I failed. I got excited. That's the probability formula for or. So in this case, I go, okay, well, we know Stat 119 is 20%. We know graduating 4 years, 40%. But there are going to be students who did both, graduated in 4 years and took Stat 119. And since we were told they're independent, we can, in this case only, multiply those two probabilities together to find that overlap. So this will be 0.08. So 8% of students will have done both. So this will be 0.52. So that's one of my favorite things to ask. In fact, you're going to see that on the Kahoot that we'll start class with, is asking independent and or, because it requires you to use the or formula and the independent rule together. If a question asks you to test if two events are independent, you have two ways. You can do either of these, whichever makes you happier. This one has a kind of better feel because you can write out a little sentence about, females are more likely to own a pink shirt than males. We saw 82 versus 49 or whatever those numbers were. Or the English and math question we saw in our class. But the first one is a little bit easier sometimes to actually calculate, even if it doesn't give you a great reasoning for why the two events have some dependence going on.